Hello all, let's start section 1.6. 1.6, other types of equations. It means in this section, we are going to solve polynomial equations that they can be any degree to some extent, not all of them. We will cover radical equations. It means roots are involved in your equation and you solve. And the third type, absolute value equations, correct? Again, maybe I'll do 3 videos or at least minimum 2 videos to cover this section for you. Let's start with the first part, which is polynomial equations. There are different types of polynomial equations that at least 2 types of them, we already know them by their special names. For example, if I write 3x plus 5 equals 14, definitely say, oh, it's a linear equation. Yes, it is a linear equation, but the general name is polynomial equation, correct? Or if I write 2x squared plus 7x plus 4 equals 0, yes, sir, this is quadratic equation we already solved. Yes, it is a quadratic equation, but still we call it polynomial equation. Or if I write x cubed plus x squared equals 4x plus 4, the special name for this equation will be a cubic equation. But in general, we call it a polynomial function. Let me explain something to you. I don't know how much you remember from your previous class. What is actually polynomial? Which kind of algebraic expression we call it polynomial? If you don't have equal sign, if I write, for example, x squared plus 2x minus 4, we call it an algebraic expression, correct? At the same time, we call it polynomial. Or if I write x to the power of 2/3 plus 3x, it's another algebraic expression. But what is the difference? I call this one polynomial. This one is not polynomial. Or if I write 2 plus the square root of x, it's an algebraic expression. But is this a polynomial? The answer is no. In your polynomial, you can call an algebraic expression a polynomial if you don't have radical sign in it, if you don't have a rational exponent. Because if you have a rational exponent, you cannot call it polynomial. If there is a radical involved in your expression, you cannot call it polynomial. That's what you learn in intermediate algebra, even in beginner algebra. Just here did a quick review. I don't want to focus on this, that why we call it polynomial equations, correct? Why we call polynomial equations, which kind of equations they are polynomial. Now, at least the first type, second type, if I erase the others to do not confuse you, the first type and second type, the first two, we already learned different methods to solve them. There are other types that you can solve it by factoring. We just cover those types here in the first part of section 1.6. For example, cubic functions. I'm talking too much, I know, but I don't want to just teach you with examples. I don't want to just show, oh, we call it cubic functions and you solve it this way. I want to give you a little bit history about this. For some of you, maybe you do major in math, or even you are not a math major, but you are interested to know a little bit about who found them, who work on them, and that's kind of general knowledge. The cubic functions, or not functions, I'm sorry, the cubic equations, one of the mathematicians, but I can say unfortunately, many people don't know him as a mathematician because he has very, very beautiful, beautiful poems. Everyone is thinking that, oh, yeah, he had only poems, and even those poems are translated in English. His name is Omar Khayyam. I think there is a documentary that if you go to YouTube about Omar Khayyam, there are many of them, but the one that's especially created on the math part, he was also a philosopher, he was also a mathematician. His focus was on cube equations. Cube equations, some of them, they are easy to solve if you can factor, but the other ones are really kind of tricky to solve. His focus was on cube equations. He tried to find solution for the cube equations, and also he worked on the cube functions. Correct? But anyway, let's start with polynomial equations, different types of them that you can, they have different degrees, but you can solve it still by factor. Let's start from example number 1 of your book. You are solving polynomial equations by factoring, correct? Example number 1. 3x to the power of 4 equals 7x squared, 27x squared. To solve this equation, the first thing to do, I want to bring all the x's to one side and I'll make the other side of the equation 0. It means the first thing to do, I will subtract 27x squared from both sides. Then I'll get 3x to the power of 4 minus 27x squared equal 0. Correct? Look at this, the left side. Look at this algebraic expression, or look at this polynomial. Can I apply GCF factoring here? Definitely yes. Remember the day that I had a little bit lecture on factoring, I told you that whenever you are looking to a polynomial, to factor, the first thing to look is if you can take something common, if you can apply GCF. Is there a GCF between these two terms? Definitely yes. What is my GCF? My GCF is 3x squared. Then I'll open a parenthesis here, and basically what I do, I'll divide here by 3x squared, and I'll divide here by 3x squared. And I'll write my answer inside the parentheses. 3x to the power of 4 divided by 3x squared only gives you x squared. Minus 27 divided by 3 gives you 9. And x squared cancels out with x squared equals 0. Look at here, and look at inside the parentheses. It's the difference of the squares. It means again, I can factor it, right? Then I'll write 3x squared. And how you factor the difference of the squares? You need two parentheses, right? Like this. The square root of the first term in both parentheses, one of the parentheses positive, one of them negative, the square root of 9 is 3 in both parentheses equals 0. Now, using the zero principle to solve this equation, you can set each parenthesis equal to 0. You can write 3x squared equal to 0, x plus 3 equal to 0, and x minus 3 equal to 0. 3x squared equal to 0, divide both sides by 3. Then x squared equals 0. Take the square root from both sides. Square root of x squared equals square root of 0 plus minus, but it doesn't matter because it's 0. Then x equals 0. Here, subtract 3 from both sides. X equals negative 3. Here, add 3 to both sides. X is equal 3. How many answers? At least 3 answers. What was the degree of the equation that they give me? Degree 4. If it's degree 4, it means I have maximum 4 solution or less than 4 solution. Later, when we talk about functions, the x-intercept of the functions, there you will understand the meaning that how many zeros your function has. Zeros means the solution, correct? I will explain more on that time, correct? But at least here, this equation had 3 solutions. What you use here, you have to be really good with your factoring to can solve these types of equation. My recommendation, maybe search YouTube, maybe search another website, or maybe find a intermediate algebra book and focus on factoring for a few days and try to work on your factoring to learn it better, correct? Let's do another example. X cubed, example number 2. X cubed plus x squared equals 4x plus 4. Again, first thing to do, bring everything to one side. Make one side 0, correct? It means subtract 4x and subtract 4 from both sides. Then x cubed plus x squared minus 4x minus 4 equals 0. There is another type of factoring which we call it grouping. I didn't cover this type of factoring in my lecture, but I'll explain it here in this example for you. How you do the grouping factoring. Look, if you try to use GCF, there is no GCF between x cubed, x squared, 4x, and 4. Of course, there is a GCF between x cubed, x squared, and 4x, but not between all of them. It means you cannot use GCF. But look here, if I do this, if I make 2 groups, x cubed and x squared, one group, and negative 4x and negative 4, another group, I can apply my GCF factoring on these 2 groups. How? What is the GCF in group 1? The GCF in group 1 is x squared, correct? Then x cubed divided by x squared gives you x plus x squared divided by x squared gives you 1. What is the GCF? Let me change my parentheses here because I want to put it outside. What is the GCF? What happened? Here I have 4x. What is the GCF between negative 4x and negative 4? What is common between them? The common is negative 4. Then I'll open a parenthesis and divide these two terms. Negative 4x divided by negative 4 gives you positive x. And negative 4 divided by negative 4 gives you positive 1 equal to 0. Now what you do in next step, you copy one of the parentheses. You have two parentheses totally the same. You just take one of them, which is x plus 1, and the other two terms that you took it common, which I use the red color here, which is x squared minus 4, you put it in another parentheses, x squared minus 4. Here you go. You factor that polynomial. We call this process the GCF factoring. Now, be always slow and focus. My first parenthesis, it's prime. I cannot factor it anymore. Look at the second parenthesis, the red one. Can we factor it again? Yes, it's the difference of the squares. Then I will factor again my second parenthesis. Then x plus 1 times, I'll open two parentheses here. X and x, negative 2 and positive 2, because it's difference of the squares. If you come to here, that was the difficult part. The rest is easy. Set at each parenthesis equal to 0. X plus 1 equals 0. It means x equal negative 1 when you solve. One solution. X minus 2 equal to 0. It means x equal 2. Second solution. And the last one, x plus 2 equals 0. It means x equal negative 2, the third solution. You see, you were dealing with a cube equation, and you have three solutions for your cube equation. Correct? I solved this problem using the grouping factoring. Again, Tuesday, it's an office hour. If you have time at 3 o'clock Tuesday, come online. I can help you if we have time. If there is not much questions about the homework, I can go quickly over the factoring for you there also. Correct? This was about polynomial equations that you were using only which method? Factoring method to can solve those equations. Correct? The second type of equations that I want to cover here is solving radical equations. How to solve an equation if a radical involved in your equation. To put a numeric example for you before even starting solving it, For example, if you get an equation like this, square root of 2x minus 1 plus 2 equal to, let's say, x, or a number, simple forms, right? We call this type of equations when radical is involved. Now, how to solve these types of equations? I'll explain it, give you steps, and I'll write some notes here for you. Step 1. Isolate the term that has radical and move the other terms to, how can I say, to other side of equation. That's your step 1. Let's focus on this problem. I'll show you your step 1. The term that has radical, I will isolate it in this side. And I'll move 2 to the other side because this term doesn't have a radical in it. It means I will subtract 2 from both sides. This example will be long because I'll give you notes. And actually, these notes helps you a lot to how to solve, because these are the steps, correct? It means I'll end up here with square root of 2x minus 1 equals x minus 2. I'm not going to solve this problem, right? I'm trying to explain for you the steps. That's why I just did one step. What if you get such a problem, for example, a square root of x plus 2 minus a square root of x equals 1. Now you will ask me what to do. Here, 2 terms has radical involved in it, right? If you deal with such a problem, your step 1 is to keep one of the radicals on one side and move the other radical to the other side. You should do it definitely this way. Correct? Keep one radical in one side and move the other radical to the other side. It means do this. In this example, add radical x to both sides. Square root of x plus 2 equals 1 plus square root of x. Do this. That's your first step. I give you another example also. 2 radical x plus 4 equals 8. In this example, you have to divide both sides by 2 first, because you want to isolate only your radical in one side, correct? These two cancels out. Square root of x plus 4 equals 4. That is your step 1. I put 3 different problems here. I didn't solve them, right? I just show you a step 1, what to do when you get a radical equation. Step 2, raise both sides of the equation to the nth power. Let's bring a simple kind of word here, to the index. Let's say to the index. To the index of radical involve an equation. Let's see here, the last one. Raise both sides of your equation to the index. In your book, in the steps, they mention raise both sides of the equation to the nth power to eliminate the isolated nth root. Nth root, I brought a very simple word for it, which we call it index, and I'll explain it here. N root of A. When you write a radical, we call this one index. Correct? The number that you have on the top of your radical on the left side here, we call it index. For example, cube root of 2x plus 1. My index is 3. Square root of x plus 2. No one writes here a 2 because everyone agreed that for the square root, we are not writing a 2 here. If there is no number, immediately you should know it's a square root. Correct? The fourth root of x minus 1. Your index is 4. Now, in step 2, it tells you raise both sides to the index. If you focus here on this example, square root of x plus 4, what I do in step 2, I'll raise both sides to the power of 2 because my index is 2. Correct? Step 3, solve. Step 4, check. Check your solution. Or check the solution, not your solution. Let's say check the solution. correct? These are the steps that you can solve any equation involving radicals, correct? Now I'll do 2 to 3 examples for you to show you how you can deal with the equations involving radicals, correct? Example number 1, I'll copy it from your book. I'll copy that one. Solve square root of 2x minus 1. I think we already copied this problem. Plus 2 equal x. Step 1, isolate the radical and move the other number to the other side. I will subtract 2 from both sides. Then square root of 2x minus 1 equals x minus 2. Step 2, raise both sides to the index. My index is 2. I'll raise both sides to the power of 2. Step 3, solve. You see here, radical cancels out with the square root, with a square. What you left with is 2x minus 1 equals right side, a minus b squared. If you don't remember the formula, actually you should have, but still you can do this. X minus 2 times x minus 2. Multiply it, use the FOIL method, simplify, and write your answer here. But if you remember this formula, a minus b squared equals a squared minus 2ab plus b squared, in one line you can write your answer here. The square of the first term, x squared, minus 2 times this times this. 2 times x gives you 2x, 2x times 2 gives you 4x, plus a square of the second term, 4. If you can't do this, please use the FOIL method here, distribute, and then simplify your answer here, correct? Now, solving, I have to move everything to one side, correct? Everything to one side. It doesn't matter which side, correct? Subtract 2x and add 1. Subtract 2x and what? Add 1. Make one side 0. 0 equals x squared minus 6x plus 5. Or if you want to write it in a nice way, x squared minus 6x plus 5 equals 0. Now, you don't have radical anymore. It's a very simple quadratic equation. Can we factor? If we can factor, yes. If we cannot factor, you have your quadratic formula. You have the factoring method. Which method you want to use, you can use. Or completing a square, which you don't like to do that, right? Any method. Let's factor this, if it's possible. It's a trinomial. X and x, two numbers to multiply gives you positive 5. To add gives you negative 6. Of course, negative 1 and negative 5, right? Because if you multiply negative 1 with negative 5, and it's the only factor of 5, it gives you positive 5. And if you add these two, it gives you negative 6. Then x minus 1, x minus 5 equals 0. From here, x minus 1 equals 0. From here, x minus 5 equals 0. X minus 1 equals 0, it means x equal 1. X minus 5 equals 0, it means x equal 5. Last step, check please. When you are dealing with radicals, please check your answer. How? I'll show the check here for you. The actual given problem was square root of 2x minus 1. Am I right? Yes. Plus 2 equal x. When you check, it means replace your x with its value for each answer. Here, x is 1. I'll replace x on both sides with 1, and I see if it works. Correct? Then the square root of 2 times 1 minus 1 plus 2 equals 1. 2 times 1 gives you 2. 2 minus 1 gives you 1. Then the square root of 1 plus 2 equals 1. Correct? The square root of 1 is 1. 1 plus 2 equals 1. Is this 1 plus 2 equals 1? You end up with 3 equals 1. Is this a true statement? Is 3 is equal to 1? No, it's false, right? It's a false statement. Then x equal 1 is not the solution for this equation. Even you solved it, but it's not the solution. That's why we never check the answer for linear equations. Oh, at low level, yes. They check, they want to make sure that they solve the problem correct. We never check our solution for quadratic equations. We never check our answer for polynomial equations because they always work. One of the types of the equations that you have to check your answer, I talk about rational equations, correct, if you remember? And the second type is the radical. And the fourth type, you will see in your book, will be logarithmic equations that you have to check your answer, correct? Now, let's check the second answer. Again, your equation is square root of 2x minus 1 plus 2 equals x. Let's this time use 5, our second answer. Then square root of 2 times 5 minus 1 plus 2 equals 5. 2 times 5, 10. 10 minus 1 gives you 9. Square root of 9 plus 2 equals, is this equal to 5? Let's write this way. Square root of 9 is 3. 3 plus 2, 5. 5 equals 5. A true statement. Then x equal 5 is the only solution for this equation. On a test day, maybe you see I put one of the answers x equal 1, the other one x equal 5, and the next, because it's a multiple choice, you will see only x equal 5. Of course, the other one will be with negative or something. If you do by mistake immediately without checking, oh, I solved it, x equal 1, x equal 5, that's A, because professor put x equal 1, x equal 5. That's the solution. You will lose the point because you didn't check. The next answer is only x equal 5. You have to be careful. That's why you have to do always checking. Correct? Example 2. Which type I want to cover here for you? I don't want to jump really to difficult ones for you. Let's go a little bit slow. The third one, not difficult, I'll do a complicated one. But let me see if I can find something for you. Let's do this one from your book. Square root of 3x plus 1 minus square root of x plus 4 equal what? In this problem, you see two radicals are involved in one side. If you focus on the steps, I told you that if you have two radicals on one side, keep one of them in one side and move the other one to the other side. It means my first step is to add square root of x plus 4 to both sides. These two cancels out, then I'll end up with square root of 3x plus 1 equals square root of x plus 4 plus 1 outside. Now, second step, square both sides. Because your index is 2. Correct? These two cancels out. Then 3x plus 1 equals, oh, the problem is on the right side, correct? If you are really good to use a plus b formula, a plus b squared, do it. Why not? A squared plus 2ab plus b squared. If not, please go this way. If you cannot use this, I don't want to use it. I can do it here really fast, but I don't want to see that you are lost. Correct? I want to, maybe I'll do it on this side for you. You have to multiply square root of x plus 4 plus 1 with square root of x plus 4 plus 1 using the FOIL method. If I use the FOIL method, the first term multiply with both, which gives me square root of x plus 4 times the square root of x plus 4 gives you a square root of x plus 4, two of them square, right? Square root of x plus 4 times 1 gives you a square root of x plus 4. Now, multiplying the second term, 1 times the square root of x plus 4 gives you square root of x plus 4. And 1 times 1 gives you 1. Here, cancels out, x plus 4 plus, you see you have two square root of x plus 4 plus square root of x plus 4. It gives you 2 square root of x plus 4 plus 1. Combine like terms, x plus 5 plus 2 square root of x plus 4. If I use the a plus b square formula, I'll end up with the same thing. Correct? Just copy this answer here. X plus 5 plus 2 square root of x plus 4. These problems, when you get two square roots or two radicals on one side, usually these problems are a little bit longer, not difficult. They're longer. What you do here, again, because radical is involved in your problem, you have to move the terms that they are not under the radical to one side and isolate your radical on the other side, and again repeat step 1, correct? Step 1 and 2. what I do, I'll subtract x and subtract 5. Be careful, you cannot subtract 2 here because it's 2 radical, correct? That's attached here. You cannot subtract that one. Here, minus x minus 5. 3x minus x gives you 2x. And positive 1, negative 5 gives you negative 4 equals 2 radical x plus 4. Remember, I told you if you have a number outside, what you can do, you can divide both sides by this number. Divide everything by 2. These 2 cancels out. X minus 2 equals, these 2 cancels out, square root of x plus 4. Now repeat step 2. Raise both sides to power of 2. It's a longer problem, but still you're repeating and repeating the same thing, correct? Here, using a minus b squared, or you multiplying 2 parentheses the same, you will end up with x squared minus 4x plus 4 equals, this side cancels out, you end up with x plus 4. Now move everything to one side, correct? Subtract x, subtract 4. Subtract x, subtract 4. X squared minus 5x. Here, these 2 cancels out, equals 0. Now, how to solve this one? You see, you can use the GCF. You can factor x here. X parentheses x minus 5 equals 0. From here, x equals 0, one of the solutions, and x minus 5 equals 0, which is x equal 5, another solution. Last step, you have to check your answer, correct? If you plug in 0, I don't want to show you again the process of the checking. Please plug, but in this problem, I know x equals 0 is not the solution. Only x equal 5 is the solution. But how to know? I show you the process in first example. Plug in these numbers to your equation and check your answer. This was the second type of the equations that I discussed in 1.6. I'll stop the lecture here because I don't want to do the other 2 types, that one of them is rational exponents and the other one is absolute value. I'll cover those 2 in the second part of this video. I'll stop the lecture here. See you in the second part of this lecture.